Chapter 2, Lesson 1, Solve Equations with Rational Coefficients. So what we're going to learn with this lesson is how to solve equations using the inverse property of multiplication and solving these equations with rational coefficients. So there are two vocabulary terms that we will be using in this chapter starting with this lesson. First of which is our multiplicative inverse. And what our multiplicative inverse is the number that when multiplied by a given number results in a product of 1. So, for example, if I had the number 4 and I wanted to multiply it by something and it equaled 1, the multiplicative inverse would be its opposite, which is 1 over 4. Because what ends up happening when I multiply this, remember we can make a whole number a fraction by sticking it over 1, and when we multiply this fraction we go across the top. Well, 4 times 1 gives me 4, and on the bottom 1 times 4 also gives me 4, and 4 over 4 reduces to 1. So this is what we would call the multiplicative inverse. Our other term is coefficient, and our coefficient is the numerical factor of a term. So an example would be if I have a term of x and my coefficient is the numerical factor of this term, that may look like 2x. So our coefficient is going to be that number that is attached to our variable. So the first thing we're going to talk about is our inverse property of multiplication, or it's the product of a number and its multiplicative inverse is 1. So like we talked about with the vocab, when we have a term and we want to multiply it by something to equal 1, we're just going to flip it. So in this case, if I had 7 over 8 and I multiplied it by its multiplicative inverse, which is 8 over 7, when we multiply, this would be able to be reduced down to 1. The same thing works with negative fractions. If I had negative 3 over 2, we would just flip that numerator and denominator and multiply by negative 2 over 3, and that would also give us a 1. So when we think about this in our symbols or our notation, when I have a over b, what we're able to do is flip it and multiply by b over a, and this would give us 1. But this would only work when a and b are not equal to 0. So what we can do with this multiplicative inverse is use it to help us solve our equations when we have these rational coefficients. So in this case, I have 3/4 c equals 18. Now, when we're solving for our variables, we always want to undo the operations around it. So in this case, I have 3/4 being multiplied by my c. So our initial reaction is to divide if they are originally multiplying. But because it's this rational coefficient, or specifically a fraction, when we divide, it can be a little messy. So what we do instead is use our multiplicative inverse. Our multiplicative inverse you may have seen before and learned it as our keep, change, flip. So when we think about this keep, change, flip, remember that means that we're going to keep our original fraction. Instead of dividing, we're going to change it to multiplication. And then the flip is when we are flipping that numerator and denominator. So in this case, we're keeping 3/4 and we're multiplying by 4/3 on both sides. So when we look at this, we can actually divide by common factors. My 4s, when I cross reduce, become 1, and my 3s also become 1. So we have c. And because what we do to one side of the equation, we have to do to the other, we're going to multiply 4/3 by 18 And remember, we can write our whole number as a fraction by sticking it over 1, and again, cross-reduce. So in this case, we'll end up with that 4 times 6 to give us 24, because on the bottom, 1 times 1 would give us 1, but we can write that 24 over 1 as a whole 24. And of course, when we are solving any of our equations, we always want to check it. So when we check, that's when we take the solution found, in this case 24, replace our variable, or c, and then we just simplify to see if we get a true statement, which we end up getting. So I would like you to pause the video and try to solve for A. When we're solving for A, again, we can see we have a rational coefficient, that 2/3, and instead of trying to divide by that fraction, we can use our multiplicative inverse to help us solve. So we can keep our original fraction, change our division to multiplication, and flip that fraction to 3 over 2 and multiply on both sides. Well, when we cross-reduce, I end up getting 1. So we'll have A. And on the other side, remember, a whole number can become a fraction by sticking it over 1. And in this case, I can cross-reduce as well. So now I can do 6 times 3 to get 18. 1 times 1 gives us 1. And any number over 1 we can write as a whole number. Now, once we get that solution, though, we want to check it to see if it's correct. So we'll just take it and plug it back in for our variable, or in this case, A. When we do our 2/3 times 18, we could make 18 a fraction by sticking it over 1. And we can look to see if I can cross-reduce, which 3 and 18 reduce to 6 and 1. So now I have 2 times 6 on top, which gives me 12. 1 times 1 gives me 1. And again, any number over 1 we can write as a whole number. And 12 equals 12. So that tells us that our solution of A equals 18 is correct. Now, another type of rational coefficient is a mixed number. When we have these, what we can do is actually take those mixed numbers and write them as improper fractions. Because then what we're able to do, if we're trying to get that s by itself, is we could take those same steps using our multiplicative inverse and multiplying by 2/3 on both sides. We're able to cross-reduce, and in this case we get s equals 11. Well, again, we always want to check to make sure that our math was correct. So taking our 3/2 s equals 33 over 2. I'm going to replace my s with 11. I can make my 11 a fraction by sticking it over 1. I can't cross-reduce, so I'm just going to multiply across the top. 3 times 11 gives me 33. Multiply across the bottom. 2 times 1 gives me 2. And 33 over 2 equals 33 over 2. So we know our solution of s equals 11 was correct. So again, I would like you to pause the video and try and solve for B. We can start by rewriting our mixed number as an improper fraction. And in case you forget how to do that, we can take our whole number, multiply it by the denominator, and add the numerator. So in this case, 2 times 4 gives us 8. And then 8 plus that 1 gives us 9/4. So now we can take our multiplicative inverse, 4 over 9, and multiply it on both sides. I know when I cross-reduce, I'll end up getting 1. So we'll end up having 1b, or b by itself. I can stick 18 over 1 to make it a fraction. I can cross reduce and get 2 and 1. And now I can just multiply across the top. 2 times 4 gives us 8. 1 times 1 gives us 1. And any number over 1 we can write as a whole number. And again, we want to check this. So we'll plug 8 back in for B. I can make my B a fraction, my 8 a fraction by sticking it over 1. And I can actually cross reduce to 1 and 2. Multiply across the top. 9 times 2 gives us 18. 1 times 1 gives us 1. And we end up with 18 equals 18. So we know our solution of B equals 8 is correct. Another type of rational coefficient is a decimal. Now, with our decimals, we can proceed with our regular inverse operations. So in this case, my 0.45 is trying to multiply my n. So to isolate my n, we can actually divide. And when we divide on both sides, we'll get 7. And just like our other problems, we can take that solution, plug it back in for our variable, and simplify to see if it is correct. So take a second and try and solve for our n. Since we have a decimal as our coefficient, our 0.9 n, they are multiplying. So we can do the inverse operation, which would be to divide by that 0.9 on both sides. And what we end up getting is a whole number of 12 equals our n. And of course, as always, we always want to take our solution and plug it back in. So in this case, we want to do 0.9 times 12. And when we simplify, we get that 10.8 equals 10.8. So we know our solution of n equals